Hi, my name's Kate Nelson, and I'm an assistant professor in geography and geospatial sciences at Kansas State University. I'm also the lead investigator for the Diversity of Agricultural Landscapes project, which is funded by the United States Department of Agriculture. In this video series, we're going to provide you with some basic information and key insights and findings from the Diversity of Agricultural Landscapes project. In this first video, I'm going to tell you a little bit about some of our quantitative modeling activities and what we've found. One of the key questions that this project looks at is the question of how diversity in terms of different kinds of land covers and land uses across the Earth's surface in agricultural systems, what we're calling landscape diversity, is related to agricultural productivity and specifically to the yields of some of the top commodity crops in the US, corn, soybeans, and winter wheat. Now, this question is derived from theories about ecosystem services in agricultural systems, where it's been hypothesized that for an agricultural system, when you're looking at things at a very fine scale, say at a plot or a field scale, relatively small increases in diversity can sometimes lead to very large improvements in the provisioning of ecosystem services. And these ecosystem services then, of course, in turn support agricultural production. That's represented by the curves 1 and 2 in this figure. Curves 3 and 4, however, represent what is expected to happen when we look not just within field or within plot, but when we start looking across farms and across entire regions. So when we start looking at these larger landscape scales, we believe that much larger increases in diversity are necessary before we can realize significant gain in ecosystem services. So this part of the project aimed to examine this relationship and determine to what extent it holds for crop production in the US. To start looking at this, we used land cover data from USDA's cropland data layer. This information provides a picture of the land cover and land use across the lower 48 states on an annual basis, where the surface is divided up into 30 meter by 30 meter squares, and each square is individually classified as a different type of land cover. Those land covers could be things such as forest cover, grassland cover, developed areas, but also this particular piece of data has a strong emphasis on crop types. So this image here is showing us an area in western Kansas where we have individual 30 meter by 30 meter squares that are classified primarily as wheat, corn, sorghum, or grassland or pasture. So we use this land cover information then to construct a data set of diversity metrics. There are lots of different diversity metrics, and here I'm just showing you one example. This metric is called Shannon's Diversity Index, and it measures diversity in terms of the number of unique different types of land covers, as well as the amount of area that each land cover takes up. So it's looking for both lots of land cover types, but also relatively equal areas to have a rating of high diversity. Now, we built this metric for each county. So in the example provided here, a high value indicates in dark green would indicate that you have both a lot of different types of land covers within a single county, and that those land covers have a relatively balanced amount of area within the county. Now, we built these data sets of metrics for every county in the lower 48 states from 2008 to 2018. We then related this information about county diversity in land covers to yields for corn, soybean, and winter wheat across counties in the U.S. And we did some modeling. What this modeling generally shows us is that, again, I mentioned there's multiple different types of diversity metrics. We can see that the relationships between yields and diversity are slightly different for different types of diversity metrics. On the top, we have a metric called richness, which is just the count of unique land uses. And on the bottom, we have Shannon Diversity Index, as I just described. So the shape of these curves are slightly different, but for all of the diversity metrics, we're pretty consistently seeing that increased levels of diversity are associated with higher yields. So some of the main takeaways of this quantitative modeling exercise is that as diversity increases, yields also tend to increase. Okay? And this is for counties in the US. We've also done modeling that shows that high levels of landscape diversity are associated with greater yield stability and also with greater drought resistance. Now, while we don't know the exact mechanisms that lead to this positive effect of higher diversity being associated with higher yields, what it does suggest is that increasing the diversity across farm operations within a county, as well as just within a single farm operation, can lead to potential benefits in crop yields and the provisioning of ecosystem services across larger areas. Thank you. I hope you'll tune in for our next update video. Please feel free to reach out at any time with any questions or comments or suggestions. We do appreciate your input. Thank you.